Okay, we're back. And during that break, I want you to know that I had a granola bar, and it was quite tasty. Now, I don't know if you noticed the difference in the time lag there, but I do. Oh, lost my pen. Okay, so we understand this statement here, or this statement here about the mean of a plus bx is equal to a plus the mean of x, which means that the mean changes by the multiplication, the coefficient, and the addition of the constant. Excuse me. Mean changes by the multiplier and the addifier. Okay, now we've got another statement here. The mean of x plus y. So now what I have here is I actually have two different distributions. I have distribution x and distribution y. And I'm going to combine them, like SAT math and SAT verbal scores. Okay? And what this is saying is that is equal to the mean of x plus the mean of y. So what we're going to say with this is, if I have two different distributions, SAT math, SAT verbal, and I'm going to combine them to get SAT overall score, I could take each math and each verbal score and combine them. So create a list of this and create a list of this. Now, important is that they have to match up in some way. That's really kind of important, is that they have to match up in some way. And so I take math and I take verbal and I combine them, and what I could do is I could add them all together and then take the average of all of those. But what this statement is saying here, instead of doing that, if I just really want to talk about the average, I could find the average of the SAT math and the average of the SAT verbal, and I could combine them. So I can combine averages. Averages will add. And consequently, what this is also saying is that averages are going to subtract as well. Okay? Okay, that's lovely. Great. Let's skip that. Let's skip that. I don't want to talk about this. All right. Now, here it says the variance of a discrete random variable, and this is the formula for the variance. And the variance, we said, is the standard deviation squared. So here's the formula for the standard deviation of x. The variance is going to be written as the standard deviation squared. And the formula for the variance is equal to each value of x, x sub I, minus the mean, the mean, there we go, the mean of the distribution. I have to square it, I have to multiply it by the probability associated with this x. Okay? And then what I have to do is I have to sum them up. So I take the first x, I subtract the mean, like for our dice one, I say my first value is 2, I'd subtract the mean of 7, I would square it, then I would multiply it by the probability of 1 over 36. And then I would do the same thing for 3. 3 was my second value. 3 minus 7 squared times 2 over 36. And I would add all those together, and that would give me the variance. And then if I wanted the standard deviation, I would then have to take the square root of that. That's a lot of work. My personal opinion is I'm not doing all that work. My calculator is going to do that for me. We're going to see how we're going to use the mean, and we're going to actually do all the work on the mean because it's going to be easier for us. Calculator is going to do the standard deviation for us. For the most part, we're going to let the calculator do the standard deviation for us. Because if they give me a big list of numbers here, this is a pain in the tush. And my tush is tender. Okay. All right, so rules for variances, and we're going to change this, okay? Rules for variances and standard deviations. If x is a random variable and a and b are fixed numbers, then, and this says the variance of a plus bx is equal to b squared times the variance of x. We're going to blow this off completely, that formula. I hate this formula. Here's what we're going to say. The standard deviation of a plus bx. So we're going to talk about standard deviation here. The standard deviation of a plus bx is equal to b times the standard deviation of x. Again, this looks like, oh my goodness, this is all a big algebraic mess here. We've done this before. We've done this twice. And we're going to go back and we're going to take a look at how this is done. So let's go back to this page right here of our information. We've got the list of L1, which is 1, 2, 3, 4, 5. So let's break out the eraser here. And I'm going to get rid of this. And I really should know what the standard deviation for 1, 2, 3, 4, 5 is. But to be honest with you, I forget, and I'm not going to go figure it out real quick, so I'm going to cheat. I'm going to cheat horribly, and I'm going to say the standard deviation for L1 is equal to 1.2. All right, so what would happen if I added, let's take this list. I'm going to take L1, and again, I'm going to add 3 to it. So what happens if I take this list and I add 3 to it? What do I get? I actually get a distribution, and think about where it's at. It's right here, if we think about number line. It is 4, 5, 6, 7, and 8, okay? That's a lovely 8, by the way. 4, 5, 6, 7, 8, okay? So everything has shifted to the right this far. The mean changed by 3. We saw that already. What about the standard deviation? Did the standard deviation change in this at all? And the answer that we saw before was, excuse me, no, it doesn't. Because when I added that constant, all I did is I took that distribution and I shifted it to the right, but I didn't change how far it spread out. It didn't spread out, it didn't contract. So the standard deviation, or the spread of this, is going to be the same. And what we said is we said standard deviation is not changed by the addition of a constant or the addifier. So I sit there and think, okay, look, here's my standard deviation of L1 plus 3. Is it changed by the addition? And the answer is no. What's the standard deviation? It's going to be the standard deviation of L1. It's not affected by the addifier. Okay, so let's go back here and look at this. Because here's our statement right here. Standard deviation of A plus BX. A is the addifier. Notice it's not in this statement at all. It's gone because standard deviation is not affected by the addifier, by the addition. Because when you add, you're just shifting it to the right or to the left if you're subtracting. All right, so let's go back and look at this again here. Okay, so I got to erase because I need the space. So let's take L1 and let's multiply it. Let's multiply it by 2. Well, we did 2 last time. All right, that's fine. Let's take L1 and we'll multiply it by 2. All right, so what happens in distribution? It becomes this. It becomes 2, 4, 6, 8, and 10. Okay? And I've tried to put that in frame here. Now notice that it's spread out. Okay? Has the standard deviation changed? Yeah, this distribution is more spread out. Standard deviation has changed here. How much? Well, as we found out before when we did this, is that if I want, it's changed by 2. And what we did is we said, oh, let's take this standard deviation of L1 and let's multiply it by 2. So 2 times 1.2 was 2.4. So when I want to find the standard deviation of 2 times L1, all I have to do is take that constant, that multiplier, and say, oh, this is 2 times the standard deviation of L1. 2 times 1.2 was 2.4. And that's exactly what this is saying right here. I'm multiplying this distribution of x by the constant b. So my standard deviation is b times the standard deviation of what was the standard deviation for the distribution. So standard deviation changes by the multiplication but not by the addition. So that means the standard deviation changes by the multiplier but not by the addifier. Addifier does not change. So when you see a question like this and it says, okay, here is my distribution and I'm going to apply some function to it, and we want to find the mean of that, and I want to do the exact same thing. Let me give myself a little bit of space here, and I want to find the standard deviation of A plus BX. Ask yourself, does the mean change by the multiplier? Yes, it does. Does the mean change by the addifier? Yes, it does. So you multiply and you add with the mean. Does the standard deviation change by the multiplier? Yes, it does. Does the standard deviation change by the addifier? No, it doesn't, because it's just a shift. It doesn't change the spread. So standard deviation is just the constant b times the standard deviation of the distribution. Standard deviation changes by the multiplier. Stop that. Stop that again. Mean, however, is changed by both. So this is the constant, the addifier plus the multiplier times the mean. Mean is changed by the multiplier, and the addifier standard deviation is changed just by the multiplier. All right, coming back after the break again.